Section 6.2 Trigonometric Equations. We want to solving a trigonometric equation by linear methods. So we want to solve this equation, and we know that the data will be in the interval from 0 degree to 360 degree. If you guys remember, we covered this topic in the session 3.3 already. You could review the video lecture from the session 3.3, example 5. It's really similar. We want to solve the equation and then we want to find out the s. Okay, you could review a little bit here. And we're gonna cover it one more time. But before that, I want to remind you guys about the reference angle. Okay, this is from the session 2.2. Some students told me that they don't remember what is a reference angle. A reference angle for an angle theta is the positive acute angle made by the terminal side of angle theta and the x-axis. For example, in the quadrant 1, your reference angle will be next to the x-axis. So angle theta will be equal to the reference angle. Quadrant 2, reference angle will be next to the x-axis. So this is gonna be my reference angle. If we know about the reference angle and we want to find the angle theta, what are you gonna do? You're gonna use 180 minus the reference angle. Quadrant 3, next to x-axis. So this is gonna be your reference angle. So you're gonna do 180 plus reference angle. That will be equal to angle theta. And then the last one, that will be 360, the whole angle, minus reference angle. That will be equal to your angle theta. Okay, now let's try to do this example together. So we have 2 sine theta plus 1 equal to 0. And then the angle is from 0 degree to 360 degree. Keep in mind that if the given the interval is degree, then you're going to use the degree. If the given is the radian, then you're going to use the radian. Okay, solve this guy. We're going to subtract 1 for both sides. And then divide it by 2. Okay. Before we're working on it, we have to think about it. What is the reference angle? Okay, we don't care about the side right now. Okay, I'm gonna look at it. Sine theta equal to 1/2. So what is the reference angle? Reference angle will be equal to 30 degree. Okay, you guys remember the special triangle, right? 30, 1, 2, square root 3. And this is going to be 60. All right. Okay, now sine theta equal to negative 1/2. The negative sign here telling us which quadrant will be for your theta. Sine is negative. So that will be quadrant 3 and quadrant 4. So first, I'm going to work on the quadrant 3. So remember that quadrant 3, the reference angle in the quadrant 3 will be like here, 30 degree. So how can we find the angle? The angle will be starting from the 0 here until here, okay? The green one will be my theta. So theta will be equal to 180 degree plus the reference angle, which is gonna be 210 degree. And then, how about quadrant 4? Same thing, quadrant 4 will be here. And then we have the reference angle, 30 degree here. Okay, so the angle will be starting from 0 until the terminal side here. So in the quadrant 4, the theta will be equal to 360 degree minus the reference angle, which is gonna be 330 degree. Okay, one more time. They say the theta will be within from 0 to 360. Now I get like 2 answers. Okay, so I know the solution set So the solution set that will be 210 degree and 330 degree. Okay? So let's go back to my PowerPoint. We solve the data and then we find out the reference angle. Keep in mind, ignore the negative, okay, when you're finding the reference angle. The negative is telling us which quadrant is going to be on your data. So since it's a negative, so we have a quadrant 3 and quadrant 4. So quadrant 3, reference angle is 30, so we're going to do 180 plus 30. And then quadrant 4, so reference angle is 30, so 360 minus 30. So we got 330 degree. I show you guys the picture here also. Okay. If we want to find the all solutions, we can add the integer multiples of the period of the sine function to each solution found above. Okay. So that will be another example, 1b. We're going to do the same thing, but this time the data is no restriction. Instead of finding this, we want to find the all solution. Okay, all solutions. So for the first one, for the quadrant 3, we find it out. It's supposed the first angle be 210. So we do have the first one, 210 degree. And then if we keep going on it, we're going to go one more circle, means we're going to add 360 degree, right? That will be the second solutions. If I'm going to keep going, if I get one more here, means I'm going to add 360 degree again. Okay, so that would be the third solution. So you could keep adding on it. Instead of writing like that, we could do theta equal to 210 degree plus 360 and times the n. Okay, n will be the integer. When n equal to 0, we're going to get the first answer, 210. When n equal to 1, we could add it up. That will be 570 degree. We're going to get the second solution. When n equal to 2, we're going to times 2 here and then plus 210 degree. We're going to get the third solution. So this is called the general solution, or you could call this is going to be the all solution. Same idea for the quadrant 4. We'll find it out. The first angle will be 330. Okay? If I keep going, I'm going to add first 360 degree. Okay? And then we're going to keep going. We're going to get the second 360 degree. So I'm going to put the n here. And again, n is an integer. When n equal to 0, we got the first solution. When n equal to 2 or n equal to 1, when n equal to 1, we're going to get the second solution. N equal to 2, we're going to get the third solutions, and so on. Okay, so this is called the general solution or the all solutions. And one more time, if they're given the interval using the degree, you have to use the degree for everything. If they're given the radian, please find it in radian for all the solution and the final answer. Okay? So theta will be the first angle plus 360 degree n. And n is any integer. Theta equal to 330, the first angle, and then we're going to add 360 degree times n. Okay, n is talking about you're going to go one more circle, two more circle, three more circle. Okay, so this is going to be the example 1b. Okay, example 2. Solve sine theta, tangent theta equal to sine theta over the interval from 0 to 360 degree. So we do have a sine and tangent here. We could subtract the sine for both sides. And then we're going to factor out the sine theta. And then we could apply the zero factor property. So sine theta equal to 0 and tangent theta minus 1 equal to 0. So we do have a two equation here. Sine what angle equal to 0. Theta can be equal to 0, 180, or 360, right? Oh, cannot be equal to 360 because this is a preference. So we do have a theta equal to 0 or theta equal to 180. We do have a two answer for this guy. And then this one, we're gonna simplify it. Tangent theta equal to 1. So first, what is the reference angle? Theta pi would be equal to 45 degree. And then tangent theta equal to positive 1. So for tangent, cosine 1 and cosine 3 will be positive. Okay, cosine 1 reference angle will be equal to theta. And then cosine 3, we know the reference angle is 45, so it will be 180 plus 45, which is going to be 225 degree. So we do have 1, 2, 3, 4 answer. Caution, trying to solve the equation in example 2 by dividing each side by sine theta would lead to tangent theta equal to 1, which would only give you 45 degree and 225 degree. So we go back on this example. When you have the variable here, okay, this is an unknown, the theta. We don't want to divide it by sine theta for both sides. If I divide it by sine theta here, divided by sine theta here, I only get like this part, tangent theta equal to 1. Okay, we're gonna ignore these two answers. Okay, for this reason, avoid dividing by a variable expressions. Okay, example 3. Tangent square x plus tangent x minus 2 equal to 0 over the interval. So it looks like the quadratic equations, right? Ax squared plus bx plus c equal to 0. Do you guys still remember how to do the factoring? Factor this guy. You should get this. Okay, tangent x minus 1 times tangent x plus 2 equal to 0. And then we're going to apply the zero factor property. Set it up, equal to 0. Okay, do it one by one. We do have a tangent x equal to 1 or tangent x equal to negative 2. So for this one, reference angle will be equal to pi over 4. Okay, don't use the 45 degree because the given interval is radian. Equal to pi over 4. Okay, and then tangent x equal to positive 1. So that will be in quadrant 1 and quadrant 3. In quadrant 1, angle x will be equal to reference angle. Quadrant 3, that will be the pi plus the reference angle, which is going to be 5 pi over 4. Okay, how about this one? Tangent x equal to negative 2. We need to use the calculator to calculate this guy. So reference angle equal to tangent inverse of 2. Use your calculator. You're gonna get 1.10715. Make sure change your calculator from the degree to radian. Okay, we are looking for the radian. So tangent x equal to negative 2. So it will be quadrant 2 and quadrant 4. So quadrant 2, that will be pi minus the reference angle. You're gonna get 2.0344. Quadrant 4, that will be 2 pi minus reference angle. You should get this one. Okay, so you have a 1, 2, 3, 4 solution. Okay, example 4. Find all solutions of cotangent x times cotangent x plus 3 equal to 1. Okay, this one, we're gonna subtract 1 for both sides and we're gonna distribute the cotangent x. So we do have a quadratic equations. And we try to factor out. It doesn't really work, right? So try to use the quadratic formula. Remember that negative b plus minus square root of b squared minus 4ac over 2a. Remember that quadratic formula. Plug it in. Try and tell me what you guys get. Okay, you should get these two answers. Okay, keep going. So now I do have the cotangent x equal to positive 0.3278. And then we have another one negative. First, take care of this guy. X will be equal to cotangent inverse of this number. And our calculator, that we don't have the cotangent. So we're going to do the reciprocal of this guy, which is going to be tangent inverse. Okay? And use your calculator. Find out what is your reference angle. Make sure you change your calculator into radian. Okay? So reference angle will be equal to 1.2768. And since tangent here is going to be positive, so positive will be quadrant 1 and quadrant 3. Same idea, quadrant 1, x, the angle x will be equal to the reference angle. And this time we try to sketch the angle x here, 1.2768. And then quadrant 3, think about it, what's quadrant 3? Quadrant 3 will be x equal to pi plus 1.2768. You're gonna see, remember on the chapter 2 we learned about it, this is called the vertical angle. These two angles are equal to each other. So I believe this is gonna be the straight line here. And think about it, from here, from the straight line here to the blue one, this is talking about the pi. So instead of rewriting two sets of the general solution, we could combine it together. We're gonna say 1.2768 plus n pi. Remember before we add 360, 360 is talking about one angle. 360 means one circle. But right now, I don't have to add one circle on it. I could add pi, half of it, 180 degree only, to get another x in here. So instead of writing two of them plus 2 pi plus 2 pi to n pi, we're gonna get plus n pi. When n equal to 0, I'm gonna get this answer. When n equal to 1, I'm gonna get the angle in the quadrant 3. When n equal to 2, I'm gonna go back to the third solution here. Okay, how about this one? I'm gonna revise it. X will be equal to the inverse of the cotangent, negative 3.30278. And then I'm gonna revise it to the tangent, so reciprocal of this number. Use your calculator to find the reference angle. Keep in mind, don't put the negative on your calculator. Remember that negative is telling you guys which quadrant is gonna be. Okay, so you should get the reference angle is 0.294. One more time, don't use the negative. Just put the inverse of the tangent 1 over this guy. And then negative is telling you guys the angle x will be in quadrant 2 and quadrant 4. So in the quadrant 2, we will have pi minus the reference angle, which is going to be 2.8476. And then We try to graph it. The reference angle here, that will be 0.294 here. So the x starting from here, to here, that will be 2.8476. And then quadrant 4, that's talking about 2 pi minus the reference angle. Okay, 2 pi minus the blue one. This is gonna be your reference angle, which is gonna be 5.9892. Similar to this part, this is a straight line. So that will be the pi here. So instead of writing two general solution, I could combine it together. So this one, that will be 2.8476 plus n pi. Okay, when n equal to 0, I got the first answer. When n equal to 1, I'm gonna get the second answer. When n equal to 2, I'm gonna go back to the third answer. Okay? Okay, example 5. Solving tangent x plus square root 3 equal to secant x over the interval from 0 to 2 pi. So for this one, tangent, that will be sine over cosine. Secant will be 1 over cosine. Even though we convert it to sine cosine, it doesn't really help. So think about it. Any formula, I could link up these two guys. Remember the identity? Okay, so first, I will square each side. I'm gonna take square for both sides here. This part, that will be a squared plus 2ab plus b squared. And then I'm gonna apply the Pythagorean identity. So secant square, that will be equal to 1 plus tangent square x. Okay, this is gonna be the Pythagorean identity. And then I'm gonna combine the 9 terms. I cancel out the tangent square x. And then I'm gonna subtract 3 for both sides. Simplify it. You're gonna get tangent x equal to negative 1 over square root 3. And then find out the reference angle. That will be pi over 6. And then negative, telling you guys that will be in quadrant 2 and quadrant 4. So quadrant 2, that will be pi minus the reference angle, which is 5 pi over 6. Quadrant 4, that will be 2 pi minus reference angle, which is going to be 11 pi over 6. So that will be the solution set. Okay, since the solution was found by squaring both sides of an equation, we must check that each proposed solution is a solution of the original equations. If you guys still remember in the algebra 2, if you try to solve the equation by taking care of the square root, you have to check your solution. Because when you take the square, the negative is going to be goes away. You may get the wrong answer. Okay, so when I take the square here, after I got the possible solution, I have to double check on it. So how can you check? You're gonna put it back to the original equation. Okay, I'm gonna plug in x equal to 5 pi over 6 for both of them. Make sure we are going to check if this is the true solution. Okay. So that will be negative root 3 over 3. And this is going to be negative 2 root 3 over 3. And this one, we're going to get the same denominator. You should get 2 pi over 3 here. You should get 2 square root 3 over 3. But on your right hand side, I still have the negative here. So they are not equal to each other. So 5 pi over 6 is not a solution. And then we're gonna check this guy. I want you guys try plug it in to see if you're gonna get the true solution. Okay, check your work. You're gonna get the true statement. Okay, so 11 pi over 6 is a solution. So for this example, we only have a one solution set, 11 pi over 6. Solving a trigonometric equation. First, decide whether the equation is linear or quadratic in form, so you can determine the solution method. For the quadratic equation, you may need to do the factoring, or sometimes you may need the quadratic formula. If only one trigonometric function is present, first solve the equation for that function. If more than one trigonometric function is present, we arrange the equation so that one side is equal to 0, then try to factor and set each factor equal to 0 to solve. So factor out and then apply the 0 property. If the equation is quadratic form but not factorable, use the quadratic formula, just like our previous example. Check the solution R in the disturbed interval. Try using identity to change the form of the equation. It may be helpful to square each side of the equation first. In this case, check for the solutions, just like our last example. That's it.